Okay, morning everyone. I'm going to start recording now. Just two announcements at least. I've uploaded all the tutorials in a compressed version to Blackboard, so you can download from Blackboard as well now. If you go to Blackboard and then learning content, I think you'll find all the tutorials. I'm going to upload the Saturday tutorials as well. You can download them. They're about half the size of the originals, so it'll save you on data there. Also, please, if you haven't allocated yourself or found a group yet, by Friday, we're going to start auto allocating from probably over the weekend. I'll do the auto allocation. So if you aren't in a group yet, you will be in a group by next week. And that will handle separately. And again, that is a practical for later on, most likely practical 9 or practical 10. We must just sort out the details around that. Today, we're going to focus on inheritance again. We're going to be spending quite a bit of time on inheritance. To get through the matters. And again, just a reminder, semester test 1 is the 3rd of September. 3rd of September during this time we are right now. And one thing to note, ladies and gentlemen, unlike last semester where you guys could automatically write the second opportunity, you cannot write the second opportunity unless you are sick. So you have to apply for the second opportunity. It's not automatically granted. We're going back to a more structured approach like we did last semester, where everyone writes a normal test. If you can't write the normal test due to an illness, you need to submit a sick note, and then we handle it from there. So you don't automatically get access to a second opportunity. You need to make sure you are ready for the first opportunity, please. It's still 2 weeks away from the test, so in 2 weeks from now, you'll be writing. Okay, the one question I was asked before we started class about calculations and if the parent class does a calculation and you need to change it for the child class, basically, how do you handle that? That is going to be the focus this morning, but I just want to go through a refresher of what we did yesterday, just to make sure everyone's comfortable with inheritance, especially with shape. Okay, just remember, please, this lecture slide on has and is very important to test your relationships, to make sure that you have inheritance and composition. In the previous years, we've done examples of like hospitals and doctors. Is a doctor a hospital? Let me ask you that question this morning. No, okay. That's saying a hospital exists inside the doctor. Keep that in mind. Can a hospital have doctors and nurses? Okay, that's composition. Inheritance. Can a doctor be a heart specialist? Okay, a doctor can be a heart specialist. It's a specialized version of a doctor. Okay, you get your specialized, your neurologist, your endocrinologist, etc. They are specialized versions of doctors. That's inheritance. So keep in mind the difference between composition and inheritance. Inheritance, the objects are the same. They are just different or specialized versions. Like we have with shape. We have a rectangle and a triangle. They both are shapes. A rectangle is a shape. A triangle is a shape. But they are just specialized versions. Now, if you look at the UML, you notice that the calculate area is sitting inside the rectangle and triangle, right? That doesn't really make sense. Is it a common calculation? Do both of them have it? Okay. So you can see they both have it. So it should actually belong to shape. Everyone agree on that one? That shape should have the method calculate area. The problem is, how do we change it if it's in shape? And that's what we're going to discuss this morning, of the ability to alter the behavior of a method from base to child. Okay? And that's what we're going to discuss this morning. Now, the functions names are not different. We're going to speak about two variations on this, so we can hopefully get a bit more clarity on it. So lecture 9 is modifying the behavior in inheritance, which is important. Remember, inheritance is quite an extensive topic, so we're gonna spend a few lectures on inheritance. So just bear that in mind. But as always with new lectures, we discuss did you knows. What are all of these an example of, ladies and gentlemen? Malware. Some of you know the correct term then, I see. Okay, these are all examples of malware. Okay, there's Trojan horses, a worm, and a virus. Is a worm and a virus the same thing? Let's see, let's test your general knowledge. What's the difference? You're correct saying they're not the same. That's 100%. But what is the difference between a worm and a virus? No, virus, computer virus, not microorganism. There, okay, you guys are starting to get the right idea. Worms duplicate, virus infiltrates. Viruses slow down machines. Worms multiplies over several machines. You're on the right track. A worm normally will duplicate itself and spread to other machines over the network. A virus won't spread over the network. A virus will stay on your machine and cause problems on your machine. It's normally will then get transferred via USB or something, depending on the virus. Okay. Trojan horses. What is a Trojan horse? And what? Any idea about the history of a Trojan horse? Because a lot of you download Trojan horses and you don't know about it. I'm going to test your knowledge of history here. Trojan War, yes, it's connected to the Trojan War. Mr. Oliver says it's a hidden virus in a program that seems legit. That's on track. The Trojan horse, I'll give you a quick history lesson. When the Trojans were fighting, they used a Trojan horse to infiltrate the stronghold of the enemy. By pretending they had lost and retreated, they built a horse statue. The Greeks, thank you. When they were attacking the Greeks, they built a horse statue because the Greeks worshipped horses at that point. They then presented the horse as a gift to the Greeks as a peace offering. What they didn't know, inside the Trojan horse was a full set of Trojan warriors. So inside the Trojan horse was a set of Trojan warriors. So the Greeks had a big party, got smashed, and then the Trojans got out of the Trojan horse and actually attacked the city. Problem is, how did they get the Trojan horse in the city, by the way? That's an interesting one. It was a Greek soldiers, I can't remember. No, they pushed it on. Yeah, they came. No, they left it in front of the gates. It was a gift, but how did they get it into the city? Which is one of more interesting facts. They brought it in. They had to smash the wall to bring it in. It didn't fit through the gates. So to bring it in, they had to smash part of their wall. And they brought it in. I stand corrected on that one. I might be wrong, but what I remember is, in order for them to bring in the Trojan horse, they had to literally destroy part of the wall to bring in the horse. It was that big. That lowered their defense capabilities quite drastically quickly. So it was a really stupid move on their side to bring it in. A Trojan horse in IT, as some of you have said, it's you download a legitimate piece of software you think is legitimate. Meanwhile, it's hiding a virus that will infect your machine, or it's hiding some sort of malware. Ladies and gentlemen, now the question is, do you have antiviruses on your machines? Okay. Are they up to date? Okay. I'm assuming those that aren't answering are updating the antiviruses. Ladies and gentlemen, do yourself a favor, make sure you get a decent antivirus. There are some good free antiviruses, AVG, Avast, Avira. There's quite a few list of antiviruses that are free and do an excellent job. McAfee is cock. I don't like it. Yes, you don't have to use McAfee. Get AVG, Avira, Avast. There's plenty of free antiviruses that will work just as well as long as you keep them up to date. An antivirus is only as good as how new it is. Okay, it depends. I use EAST. I don't like Kaspersky either. Everyone has a different opinion. I use a software called ESET. It has also a built-in rootkit and a tracker, so it does a bit more work than that. Hey, as long as you keep it up to date, it's fine. I'm not siding with any antiviruses. I just personally don't like McAfee, or some of them have been known to develop their own viruses. Before we move off this topic, what is the worst? I want to show you this quickly. I like doing side topics. So in 2013, the world's worst virus. You guys can see this. Yeah, was a CryptoLocker. Sutnex was 2010. CoinFlicker 2008. This Sutnex was one of the more scarier ones, as it was designed to destroy nuclear power plants. Okay, Sutnex was not really a friendly one. It wasn't one that you get on your machine. It was designed to destroy nuclear power plants. Yeah, a virus can lower the performance on your machine. The newer one are CryptoLockers. They will basically take all your data, encrypt it, and then hold it to ransom. So that's the newest kind of malicious malware that's going around. That's normally done to large companies. It has done to individuals as well. Ransomware, yeah, it's very, very popular right now. Depends on the virus. It can lock you out your machine, yeah. Do yourself a favor if you're interested in that, or not interested in it. Look into a thing called a rootkit. That's scarier. Keyloggers, that's not really a virus. It's just an application. Some companies do it to track their employees. Rootkits, those are more dangerous. Who's ever heard of a rootkit? Okay, I can't believe you. For those who don't know what I'm talking about, a rootkit, Google it. Unfortunately, if I have enough time, I'll come back to it at the end. Okay, my second, like rooting a machine, no, it's a bit more, it's a different type of level. The reason I actually am quite in depth in terms of security is my second focus, I guess, is security after AI. So besides AI, I also have a fair understanding of security aspects. Okay, one thing I want to discuss is method overloading before we move on, because I see some of you guys are getting confused by it. Method overloading, constructor overloading Normally, can you use a method, can you use anything with the same name in VB? Can you have a variable, two variables with the same name? No. Okay, you can't have two variables with the same name. Can you have two functions or subroutines with the same name? This is where you can. You can have two functions or subroutines with the same name. It is known as method overloading. I'll explain how. Not in different classes in the same class. Okay, you can have method overloading. Think of your constructor overloading. You can have more than one constructor, correct? How is that done? How do you have more than one constructor? Different parameters. Thank you, Mr. Beck. Now, that's the same thing for method overloading. I have three methods, all functions, determine value, determine value, determine value. The reason, if we look at the first two, x as double, y as integer. The second one, x as integer, y as double. Is the signature of these functions the same? Are the same parameters requested between the first two? No. So these are two methods with the same name, but expect different parameters or different order of parameters. The reason this one's underlined in red is I'm showing you in the last function that even if you change the name of the parameters, as long as the data type is the same, it'll cause a problem. So it's complaining that there's two methods with the same parameter set, same signature. So it's not happy. But if we have two, like the first or the last two, the parameter signatures are different. So we can have two methods with exactly the same name as long as they accept different parameters or the order of the parameters is different. Why would we do this? That's the next question. Why would we go with method overloading? And it's something you've been using the entire semester, entire last semester. You just don't know about it. Any ideas why we would use method overloading, ladies and gentlemen? Guess. Come on. Any ideas? No. Another class wants more features than the parent class. This has got nothing to do with inheritance. Calculating the same thing allows one function to have multiple different parameters. Yes and no. Okay. Convert to string. No, not polymorphism. We're still getting there. When you use convert to string, CSTR, okay, what can that accept? Text? No, but what does it accept? Integers, longs, doubles. It can accept anything converted to a string, all variable types. Thank you. It can accept all variable types and convert it to a string. How the hell does it do that? How can one function, yes, even Boolean. Overloading, there we go. Method overloading is the ability to have one function perform multiple actions based on the parameters. The one you guys are used to are cint, cstring. Hell, even your input box is method overloading. Dim x as integer, make it a string, equals input box. Now, has anyone ever stopped to look at what this big box is for? No. Okay. That is telling me there's different ways of using the input box. I can have a prompt, a title, a default response, and a position. So I can go, please enter value for X. That's what you guys are used to. But there's also a method that says, I'm going to do a title. Example of overloading. I was accepting 2 parameters. And then I could give a default value saying Bob. Now there's 3 parameters. Depending on how many parameters are passed, it invokes a different input box method. That is method overloading, allowing us to have one name for a method, but it does different activities based on different parameters. Does that make sense? Okay, so it's one method or one method name, but it can perform different activities based on what you give it. So if I actually run this one, let me cheapen this, put this in form load. Okay. So method overloading allows us to have one method name, and depending on, oh, come on, it didn't invoke the load event. I'll come back to this if it doesn't work now. No, it's not working. Okay, I'll come back to it. I want to get back to the overriding, but I need you guys to understand the difference between overloading and overriding. Here, we have the same method in the same class, or the same form even, but they do different functionalities. Is everyone okay with the overloading? Guys in chat, ladies in chat. Okay, because from here we're going to discuss overriding. Okay, I'll discuss the input box again, like maybe this afternoon. But this is overloading 2 different methods with different parameters. Okay, what we're going to discuss today is called overriding. It's a recap and inheritance. We're falling back to the example of the UJ program because this is a very nice one to illustrate what's going on. So we have the business management, informatics, mathematics. They all have, they all share this calculate semester mark, right? They all share this in common. But does each subject calculate the semester mark the same way? Okay. They all calculate the final mark the same way. We can go with that. The final mark is 50, 50, 50, 50, 50, 50 for exam and semester. Okay, that's how they'll do the final mark. But for the semester mark, that's a different story. Semester marks have a problem. I'll come back to all the details. But if you look at the semester mark here for, say, business management, informatics, mathematics, are they the same calculation? Does it change between each class? Okay. They all have the method calculate semester mark, but we needed that it can change. So what we do is we create a function, and this is correct UML. Okay, this is important to take notice of before I move on. You notice up until here, did it have Do these ones have the calculate semester mark in? These three derived or pay children class. Do they have calculate semester mark in? No. So currently we are not doing overriding. There's no overriding taking place. Keep that in mind. Indicate overriding. We indicate overriding by having the method in each one. That means we're using this method. This is not overloading. This is not overloading. This is overriding because it's in different classes. Okay. So we have a generic calculation here, and these calculations are specific to the subject. These are all specific to the subject, so they're overridden. How it works is the following. I want to get here. We declare our base class to have an overridable function. Okay, so we say that public overridable function calculates semester mark returns 0 for the UJ module. Everyone okay with that idea? So in the UJ module, we say it's overridable. That means I can change it in the base, in the children or the derived classes can change the functionality. That's the most important point. An overridable function can be changed by the child or derived class. So the base class declares it as overridable. The child class declares it as overrides. And that's the important point. It overrides the functionality. I know I skipped a lot of slides, but I want to focus on the more important things. So what he's saying here is, in the base class, there is a function called calculate semester mark. We have it. We don't know how it's calculated yet, but we will just return 0 for now. But the children class know how to calculate it. So they are going to override it. Also notice the parameters are the same, still just a bracket. So when I go into a child class that inherits, I can override the functionality, the parameter is still the same, and declare and create the functionality. So this is overrides. It changes the functionality. Okay. Now the rest, this was just showing calling the calculate final mark. Let me show you this in action. Okay, since we have some time. But you guys can look at the slides, and I'm going to show you it actually in action, and then we'll work from there. So that's actually the end of the slides. Overriding is one of the more unique features of inheritance. So let's start with a UJ module. Let's see if I can do a slightly cheaty way of doing this. Yep, there it is. I'm attempting that. But unfortunately, I've got to go through steps for it to work. Oh, damn you. Copy. Takes a bit longer. Okay. And this will return the calculate SM times 0.50 plus exam mark times 0.50. And that's going to give me an error. Yes, no, maybe, I don't know. Get rid of those dots. Okay, and we need, of course, our property methods. st1 mark integer. Oh. I can't see what you guys are saying right now. Yeah, overridable functions are ones that are common. First, I'm going to take away the overridables so you guys can see it's going to cause me a bit of grief. So let's just do the exam quickly. Let's go and create a informatics 1B. IFM 1A. Okay. Always start with your basics, option, infer, off. Now remember, how do we inherit? What's the key word? Inherits. Good. Inherits UJ module. Done. Okay. Now it's complaining. Why is it complaining? Okay. Now it's not complaining. Okay. Now this module is now in a UJ module. Remember, it is a UJ module. So it already has semester mark 1, semester mark 2, and exam. What it doesn't have is practicals. As double. Well, let's go to integer. And now I want to calculate the private function semester mark. Was it a integer? Now it's going to complain. Function shadowing overridable method declared in base, blah, 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 blah. It doesn't really like it, okay, because we have two methods with the same name, okay. We want the same name because we want the functionality. So what we do here is we declare this as overridable, overridable, overridable. So we make this overridable. That means I can change it. I'm giving the permission, I'm giving the access to the child class, to the derived class to modify the functionality. So here, all I do is I say overrides. Now why is it complaining? Oh, should be public. It must match. Careful of that. It must be public. If this one's public, your overriding must also be public. You can't change anything. Parameters have to be identical as well. That's the one difference between overloading and overriding. Overriding, we have the same parameter signature. We have the same signature for the method. Overloading, we wouldn't have the same. So now I can write functionality to calculate this one. So if I go back to the slides quickly. Multi. Okay. So this allows me to have two calculation or two ways of, not two ways, but have a specialized calculation for each child class. And that's the point of overriding, is as we move down from inheritance, so as we go, oh yeah, I forgot to, if I didn't emphasize enough yesterday, to show inheritance, it's a arrowhead pointing towards the one we're inheriting from. So inheritance in UML is an arrow pointing towards the class we're inheriting from. Everyone okay with that? Diamond for composition, arrowhead for inheritance. Okay, and the arrow points to the class I'm inheriting from. So business management 1A inherits from UJ module. Informatics 1A inherits from UJ module. Mathematics inherits from UJ module. So the arrow point is always to the class we're inheriting from. Okay. So there is another type of overriding we will show you later on, but let's first understand what overriding is, so it makes more sense to you guys now. Okay, so overridable again indicates that this function can be changed by a child or derived class. It allows us that ability to change it. Okay, and then saying override says I am going to change the functionality to something that fits my specific situation. So as we step down, you must always keep this in mind. Every time you go down in inheritance from the base to the child, it must get more specialized. It must be more specific. No. Through overriding, you can access instance variables from the child class. No. We can't access instance variables. Only if they're protected can we access them. So overloading is the same function name in the same class but different signature. No. That's overloading, yes. Overloading is the same function name within the same class with different signatures. Overriding is in different classes with the same signature. Okay, so to have a look at it again. Overriding or overrides, same function, name, different class. You must declare the base class to be overridable, and the child class gets overrides. So I can change it. Overloading, as you said, is the same method in the same class with different signatures, being the parameter signature. So this is overloading. This is overridable and override, or overriding in general. So as I make the different modules, so in case I say I make mathematics and I declare it mathematics and I inherit, I can then calculate that semester mark for mathematics based on its calculation. So I don't need to worry about, okay, where is this coming from? I just simply have to know how to calculate the semester mark. The thing is, the important thing is what it does is it shows us that all the classes are going to have the same, going to have a, where is it? They all have this calculate semester mark. Okay, this, me showing a semester mark here, here, and here calculation tells me I'm overriding the base class. By saying the name of the method again, I'm saying I'm going to override it. So there's no keyword for overriding, there's no special characters, it's just mentioning the method again that shows overriding. You guys okay at that point in UML? So in the UML, all we do is we duplicate the name. We don't have to say it's overriding. All we have to do is say we have calculate semester mark here in the base class. In the child class, we have calculate semester mark as well. That is essentially saying I'm overriding. Yes, the function must have the same data type. There must be no difference. Okay, let's test that out to see so we can see. MIDI doesn't like it. It's not happy. It doesn't like the different. So with overloading, so overriding, you must have identical signatures. You can do overriding with subroutines as well. It's not just limited to functions. It can be done with subroutines. Why would we want this functionality? Why do we need, okay, let me specify. Why do we need this functionality? Any ideas? Need understandable code. Decrease repetition. In the right track. Okay. With inheritance, calculate the common functions. Yeah, that's where we're going. With inheritance, less work, more effort to prevent redundancy. You guys are on the right track, but it's a simpler answer than that. With inheritance, we inherit functionality. I'm going to show you another thing next week with a must override. I'll tell you what I'll mention the keyword now, where we actually don't know what the outcome is of a function. So also the key difference is with a UJ module, do we know how to calculate every single semester mark for every single subject? Do we have that amount of information? No. Okay, we don't know how to calculate the semester mark for any module. But do the modules know how to calculate the semester mark? Maths, business management, informatics. They know how to calculate it. So we're saying we're going to have this common method, yes, but each base class will change how it calculates. So we're saying, yes, we're going to have the method. It's going to exist. Every class will have it. But some classes may calculate it differently. So we give the ability for the base classes to change the functionality. And that's where overriding comes in, to change the functionality. It's the same as the calculate area. Calculate area for triangle and rectangle, there should be a calculate area in the base class because it's a common method. Both of them share this. Both of them will have it. So it should be here. Okay. It should be here, but it's not. But with overriding, we can now do that. Okay, overriding, it gives us the ability to say, yes, we're going to have calculate area, and this one's going to have calculate area, and this one's going to have calculate area, but these ones are going to be different ways of calculating. It's not going to be the same thing. So the semester mark is a parent class, also be calculated. Or is it just overridable it only? Thing is, in the base class currently, we don't know how to do it. So if you look at the base class for the UJ module, we have no way to know how to calculate the semester mark yet. So we just leave it at return 0 for now. And then each base child class will then implement the correct functionality. There's another way to enforce this, which I'll show you next week. But for now, you just need to understand the ability to override and okay, there's also extending, which I'll discuss next week. Yeah. Oh, hell. Because we run out of time already. I don't want to keep you guys on too long, but does everyone okay with the idea between difference overloading and overriding? Next week, I'll show you better ways to implement it, more effective ways, because I'll show you a thing how to extend functionality, and I'll show you how to have something known as an abstract class, which will then further emphasize how these tools fit together. Would it be better to remove the calculate subroutine from the parent class and calculate semester mark in each class within each class? No, it wouldn't, because we need that ability for something we're going to do later on. Okay, this all fits together in polymorphism as well. So it's something you have to know how to do because it's going to fit later on. It's extremely useful later on with polymorphism. So I know it doesn't, it would make sense just to have it in the separate classes, but the technique we're going to teach you later on requires this ability to be there, and that's known as polymorphism. Okay. How do we use property methods from the parent class in the child class? That's fairly straightforward. See, okay, in this case, all of them are private, correct? We have our property method. So in the child class, we just call the property method. We just simply call the property method. We don't need to recreate it. We don't need to redefine it. It exists already. As soon as we inherit UJ module, we get all the public methods. So semester mark 1 is a property method. We automatically have access to it. We don't need to protect it. If you do a protected access, then you have direct access to the instance variable. That's something you can decide as a programmer, but generally you only want to, okay, let me say this now. Normally everything is private. Okay, we normally want to keep things private, only essential things, only unless there's only no other way do you go protected. Okay, rather go through property methods because they might have functionality to validate, etc. So it's important to get an idea. Protected is a quick way to access variables, yes, through the instance variable, but sometimes it's better still to go through the property method. So you can still enforce security in terms of access and control. But it all depend on what you're trying to solve. Like I say, there's not always one solution. If this is protected, so let's change this to protected, we then can access the instance variable, semester mark 1, directly because of the protected relationship inside inheritance. So since it's protected, the child class can access it only. Or we can use the property method which already exists. It just depends on how you approach the code. But this doesn't mean you make everything protected. Please don't suddenly make everything protected. That's not the idea. The idea is to still keep things as private as possible. Only the essentials you make protected. Okay. But next week I'll be showing you things I'll be showing you next week include abstract classes, extending methods, um, things that make a lot more sense. Okay. And I know it doesn't make sense right now to have this stupid method here that does absolutely nothing. But when we deal with polymorphism, this is a very, very useful functionality to have. Polymorphism is a very powerful tool in object-oriented programming. It's something you want to get to understand. And it does make programming a hell of a lot easier for large projects. So it's something that is quite important, but it requires us to have overridable and overriding methods to work. Polymorphism is only a tool that can only be used with inheritance and overriding. Else it doesn't really fit anything. It doesn't actually exist. So you're first going to understand the principles that build on polymorphism, to build up to polymorphism, to use polymorphism. And once you understand that, programming becomes a lot easier for bigger projects. Okay, so it's something we're building up to. But is everyone okay with inheritance and overriding? With regards to, are we ever told to use protected? We may, in a practical say, make it protected, but it's still up to you in terms of that final decision. We'll just question you why you made it protected. If you have a valid reason for making it protected, then it's fairly okay. But we will try to structure the practicals in such a way that we tell you what to make protected. Thing is, there's not always one solution. There's always another way to solve it. So I don't like being a lecturer that says, no, you must use this and must use that. If you understand it and can use it properly, then I'm fairly okay with it. But it must make logical sense and use the correct principles. Remember, we're trying to teach you principles of effective programming and efficient programming, not just not just solving a problem, but the ability to solve any problem. So it's more important to understand principles and apply the correct principles. But that's it for today. We're already over time. I do apologize for going a bit longer. But hopefully you've learned a bit more today, and this will definitely become a very useful tool to you as you move forward. Okay. Again, the tutorials are being uploaded to Blackboard, so you can download the tutorials there as well, at about 150 megs each. They're quite compressed compared to the original Blackboard's videos. So if you want to access the tutorials, they are there as well. That's it for today. I'll see you guys in the TUT this afternoon. We're going to go through composition a bit more this afternoon, as some students may still be struggling with that. Is the quality still good? It's the same quality as when you download off Eve. It's audible and you can see the text quite clearly. If there's an issue with the quality, let me know and I'll increase the quality and upload again. But my approach is to try to get it down to at least 150 megabytes, because I know when you download off Blackboard itself, it's about 300 to 500 megs per tutorial, which is a bit heavy. So it's reduced to quite the smallest I can make it without destroying the quality. It's still readable at least. Okay, I'll see you guys this afternoon for those who are joining us. Download a TUT Audience a gig. Okay, yeah, definitely download from. I've uploaded it to Blackboard under content, so just have a look there. You'll find all the TUTs there as well. I'll put up the 2018 past paper if I can find it. Okay. Okay, have a good day, everyone. I'll see those in the TUT this afternoon at 1. Enjoy.